This video, I'm going to talk about generics. This is something that some object-oriented programming languages do have, and I'm going to talk about generics in Java. Now, here's a case. I have created a few things for context. So I created an interface shape with a method getArea. I've created a rectangle class that actually initializes a rectangle and implements that getArea method with a length by times height, right? So the rectangle, you pass the length and the height, and then it'll give you that. We have a square class that extends rectangle, and it's initialized. The constructor has only one parameter, the side, and basically what it does is it builds a rectangle with both sides being the same. Then we have a triangle class that implements shape. It's also a shape. Its constructor takes the base, the height, the side A and side B. It sets all the variables, and then it gets the area. Now, however, this class triangle also implements another method, a getPerimeter. Okay. Now, we have another class. Let's say I want to create a class to manipulate arrays, to sort arrays, to reverse arrays, to do search in arrays, and do whatever it is that I needed to do. Now, for simplicity, I have this class that has an array of type object, and you can pass that array of type object, and it will set the array, and it will set the length for setting some variables, and you can get an element at index I, or you can set an element here at index I. Okay, so these methods work. Now, because my array of stuff, I don't want an array of shapes or an array of rectangles or an array of squares. I want any array to work. So what I'm going to do is I'm going to have the underlying structure here is an array of object type elements. Okay, so let's see how this would work. If I wanted to create an array of squares, for example, I would create an array A1. I'm just going to say it's of length 5, size 5, and I'm going to create all these squares. And then I'm gonna, I've just created a rectangle here, but I don't need that. I can create an array of stuff right there, an array of stuff, right? An array of stuff. And then I'm gonna set, A is my array of stuff, and I'm gonna set the first square in position 0, the second square in position 1, the third square in position 3, the fourth square in position 2, and the fifth square on position 4. Now, if I want to get one of these elements, examine one of these elements, what I should do is to get the element. In this case, I'm going to get position 4, the last element, and I have to cast it to a square, because as far as Java knows, this element here is an object. The underlying structure here is an object. So I have to cast it to a square and then print the area. So let's compile this thing and run it and see what happens. So I'm running it, and here's the area, 7.839 periodical. So all is good here. Now, the problem though, there's a couple of problems. So let's say I want to, because this is an array of objects, I can easily get distracted here, and put a string or any other kind of object as S5, right? Which is element 4. And I will compile. This will compile. It won't tell me anything. So if I'm working on a big project, this might just pass, right? And if my tests are done with different indices, this might pass tests as well. However, I'm going to execute this, and what happens is I get an exception, a class cast exception. And in large pieces of code, this can be hard to find out, because you're looking at, oh, these are all squares, that's square, that's fine, but it doesn't, it doesn't hold, because I need to cast this. Another thing that I might be doing is say, okay, let's say I put a triangle here, a new triangle, and then the triangle gets a bunch of numbers, so I'm going to say that. Okay, so let's say I put a triangle here, And instead, I'm going to use polymorphism here. This is a shape, and I'm going to make it into a shape, right? So if I compile this and execute it, it's going to get me the area of the triangle, 10. However, if I want to get that area, I also want to, for some reason, compute print line s dot get perimeter, okay? Because triangles do have a get perimeter method. Remember, here triangles have a get perimeter. This is not going to compile because shape objects do not have a get perimeter. You see the underlying red and then the error here. So guess what? I really need to cast it to a triangle. So there, I really need to cast it to a triangle. So what happens here is that if I try to create this class that's gonna be generic for the treatment of arrays, and this works. So if I'm gonna create a class that works to manipulate arrays or manipulate a collection of objects, right, or some kind of object, I'm always gonna have to cast that object, and I have to keep track exactly of what kind of elements that class holds, because the compiler is not going to do it for me, or not going to do it very well for me. So generics kind of solve that problem. And the way that they solve this problem is by saying, okay, you know what? This array of stuff, let's give it a type. Let's say you want an array of stuff that is going to hold squares only. Okay, square objects. All right? It would be great if you could say that, and you can. And the way you can is you say array of stuff, angle brackets, and the class of things, of elements that you want, or the class of whatever that you want to manipulate in this array of stuff. And then you say new array of stuff, this and that. Now, for this to work, I'm not going to compile this, because for this to work, I need to do something in the array of stuff as well. So array of stuff, now it's going to receive a little parameter in angle brackets, and I'm going to call that parameter capital T, all right, or capital E for element, all right? And now this is going to be the class of the underlying array. So it's not going to be object anymore, it's going to be E, all right? Now, of course, in my constructor, I'm not going to pass an array of type object. I'm going to pass an array of a well-defined type E. Whatever I put here is what I need to pass an array of in here. And you see that this is an array of type E that's going to go into this variable, which is also an array of type E. So it's all consistent. Also, when I get an element from the array, I'm going to get an element of type E. And then when I set an element, I'm going to set an element of type E into my array. So if I do that, okay, look what happens right here. This is not going to compile for a little reason here, but if I try to compile this, immediately I'm going to get an exception. First, I'm trying to put a triangle in an array of squares. That's really good, because you don't make that mistake, right? Which I could totally have made earlier. So I really need to do squares here, not triangles. Square. Oops. Square. And this is going to be a square of 4, for example. All right? That's only a square. And then here, when I say a.get, so I'm going to try and compile it again. And here, in this line, I get an error as well, because guess what? Element 4 of this array is a square. I cannot cast it into a triangle. And I do not need to cast it, actually. That's the other beautiful part. I just say square S. And of course, you know, squares don't have a get parameter, so I'm going to comment that out. Otherwise, it's going to error again. But here's the thing. It's much more transparent now that I have... okay, A1. Oh, sorry. The other thing is this A1 is not an array of objects anymore. It has to be an array of squares. All right, there you go. So I'm going to compile and execute. And now everything works. right? But the beautiful thing is that now I have an array of squares. If I want an array of triangles, I can do array of stuff, triangle T equals new array of stuff, open close, and I'm gonna give another array TA1, for example. Now I don't have a TA1, so I need to make it. So triangle T1 equals new triangle 1, 2, 3, 4. It's 4 parameters. So triangle T2 equals new triangle 5, 6, 7, 8, right? And let's say those are the only 2 triangles. So I'm going to say triangle array TA1 equals new triangle array, right? So new triangle array of length 2, and I can initialize this guy, and then I can actually, you know, this I'm just putting this triangle array here. I'm not putting the triangles in there, but I could, right? And the output is the same. But I could say, you know, T dot set triangle 1 in position 0, and I can say T dot set triangle 2 in position 1, and then I can print here. I could say triangle T, T is the array, so let's say triangle TR equals T dot get, and then the first one, for example, and then I could print the get perimeter of that TR, of that triangle, right? And that will compile. So I'm using this array T that I know has elements of type triangle, and I don't have to do any casting in my code. The compiler is doing that all behind the scenes, and everything works. So what's going on here, I have this function print array that I'm not going to use now. So I have this little class, array of stuff, that receives a generic class, and it works with that generic class. Okay, now I can also have classes with a with some other methods. Okay, so some generics in the methods, they don't have to be in the class, they could be in the methods as well, and I'm going to cover that in a separate video. But for now, you have an idea of what generics is. Underneath the scenes, though, what the Java compiler does is it makes this array of stuff exactly like we had it before, with objects, with an array of objects. And these parts here, for example, it does the casting underneath the scenes for you, right? But the thing is that generics are a great help for you to not have to worry about compiler errors. If you use generics, you're telling the compiler, hey, check these things for me and make these casts for me whenever possible. So you eliminate a source of error. So I hope you like this. For more specifics on generics, you're welcome to look at the other videos.